All right, testing 1, 2. Mic is on. Good. Good, what is it, Tuesday? Good Tuesday morning here in Canada on the East Coast. And we're back at it for some more coding game bot building. And today, I figured I would focus on optimizing my JavaScript code. Hey, Joe. How you doing? Thanks for popping by. All right, so what I'm doing today, I'm going to implement object pools because my code is just too slow, in large part because of the garbage collector just firing whenever it feels like it in the middle of my algorithm running it. And that causes timeouts. And because of that, I had to reduce drastically the amount of time I would give the algorithm to run, just to give like a little bit more a margin of error. And yeah, so I want to fix that, get more CPU cycles, because right now my bot is just not that smart, and the main reason is that it doesn't get to run enough simulations to get, you know, data that's relevant. And possibly if I get to do that, then I'll take a look and see if I can reduce object creation. I don't know how costly that is, how expensive object creation is, but I have a feeling that because of the Monte Carlo tree search algorithm and because I didn't code things in a very mutable kind of way, like I create a lot of objects instead of mutating them, which is, I think, oftentimes good practice, but in the context of code like this, where you're looking for performance, might be smart to reduce that. So I'll look at that. Then, if there's enough time, I want to implement the lookup table for the Monte Carlo tree search algorithm. I don't know how relevant that would be. Like in some types of games, it's super useful to have a lookup table. It's basically a form of caching, and the reason why it's useful is because you end up finding states in the game at many different places in the tree. So take a chess game, for instance. I might have a certain board position by going down the tree a certain way, but I might end up at the exact same board position by making different choices. It's just that so I get to the same state, but from a different road, if you will. So it makes sense when you have a game that has a lot of that to basically cache all the board states. And when you end up finding a board state that you already explored, instead of exploring everything below it, you've already done that. So why do the work again? Just reach into your lookup table and use that instead. Not all games are well suited to that. I don't know if this one will be, but we'll test that theory. All right, let's get started, shall we? With our object pooling is the first thing I'm going to be tackling. Maybe actually just before I get started with the actual code, let's do a little bit of benchmarking. I'll show you guys what I'm talking about at the same time. Um, okay, just run the code here. So I'm ranked. I'm in the bronze league right now. I'm ranked 1,100 and something. And this is a guy that is a bot that is ranked 600th. And oh, he beat me by one. But what I'm interested in, and let's go to the very beginning. All right. So as you can see, I was only able to run 2,069 simulations, which is really not a lot for the almost like 1 second that you're given of compute time at the very beginning, which means I can go 15, 15 steps deep. That's the deepest node I reached in the tree. That's not a lot considering that the game has 100 steps maximum, I guess, but some games end up finishing a little earlier than that, but from what I've seen, it's usually between 80 and 100 turns. Um, so, in order to make smart decisions, I would want to go deeper in the tree, especially in the first turn. So we're going to see if we can improve that. But where it really hurts is um, when we go to the subsequent turns, where I only get 50 milliseconds compute time, which I can't use fully right now because I have to keep like a cushion because of a stupid garbage collector. So I'm really using, I think, only 35 milliseconds at the moment. And this translates to, as you can see, I can only go 10 deep at most with 192 simulations. If we're looking at, okay, so the first move I made was casting 78. So casting 78 is this one. Right, so I just casted that. And then afterwards, my options choices were, the algorithm figures that you can either rest, yeah, that's always an option, and you can cast this one here, -1, 1. Can't cast this one because it's, it's exhausted. We've used it. And I don't have the ingredients to cast these other ones. I don't have enough stuff to actually brew. So that leaves me with rest and casting this one. Now, it estimates that I have 41% chance of winning, or basically 41% of the time that it went down that node, that it made that choice, the random playouts, the result of the random playouts is 41% winning. So I'm more likely to lose according to this. And the other choice, so that was rest, and the other choice, which is casting, is 40%. But look at that's based on like 100 visits. That's like really not a lot. For Monte Carlo research algorithm, and really Monte Carlo algorithms generally, to work properly, you need to have enough samples um, to trust your data. For instance, like if you were to write a program that would return the odds of getting, let's say, tail on a coin flip, right? There's many ways you could do that. But the Monte Carlo way of doing it is doing a bunch of coin flips and recording the result. Flip, 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 flip. And after a while, you just compute, all right, we did 1,000 flips. Out of those, 503, right, were, let's say, odds or tail, whatever. So, and that would give you a pretty close to real life result, right? The thing is, if you do that with 3 coin flips, well, you could just, like, because of randomness, it could end up being tail, 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 and then you're like, oh, your odds are 100% that you're going to get tail. No, they're not. So there's a bit of statistics involved there, but there is a certain minimal amount of samples that you need to get in order to trust the data, and I'm nowhere near that, and that's why we need to improve that. Okay, another thing I'm going to do, just to show the problem I'm having with the garbage collector. So I have made a little playground here so I can play my bot. Wonderful UI, thank you. And I want to do a little bit of profiling. Of course, mind you, this is running in the browser as opposed to the bot, which runs on CodinGame servers, running on Node, but they're both running on V8. Chrome runs on the V8 engine, so does Node. So there are similarities. And what I want to do, let's see, performance. All right, let's do this. Let's say I play this. Now my bot's going to choose something to play. So I can do next turn. And I'm going to play this. Bot chooses something else. do this, the bot chooses something else, and I'm going to do this, and the bot chooses something else. All right, that should be enough. Let's see what we get. All right. Not exactly, what do you call that? Not reactive, but, well, it's not that bad. It's, anyways, um, responsive is what it was. Okay. All right, so this is our first turn where we get about a second of compute time. So I do give the bot that much. And let's take a look at what's going on there in that um, first turn where the bot gets to think. Let's get that wide here. All right, so this is my loop function. Anonymous calls, and there's a bunch of my function calls. I'm looking specifically for, there you go. So you see all these dark orange ones. Minor GC, minor GC. Look at this one right here. Major GC, minor GC, minor G. Like, I don't know if there's a way to kind of get data out of this and sort it. But as you can tell, the garbage collector fires. Like, how many times did it fire in 1 single second here? A lot. Like, a lot. All these, like, darker yellow ones you see, orangey, whatever, that's all garbage collection, minor GC. And, okay, so some of these calls aren't that bad, 0.56 milliseconds. But, taking the amount that you see, like the aggregate of all of that, I don't know how many seconds I'm losing, or milliseconds I'm losing because of that, but quite a few, right? So cutting down on that is going to be important. Now on the first turn where I get a full second, it doesn't seem that bad, like percentage-wise, how much time is lost on garbage collect. Although it's quite a bit. But let's take a look at how do I do this? Okay, let's take a look at our first turn, which would be this one. Well, the second turn really. So this here, I only get 50 milliseconds. Okay, and so as you can tell, we've got a GC event here and another one somewhere in there, I think. Is that it? No, I don't know. Not sure. Okay, so this one doesn't look too bad. So we're really just losing about a millisecond, about 1 millisecond in here for this second turn. Let's go take another look at this one here. All right, this one has a bit more. See, I'm losing about a millisecond here and 0.74. So overall, almost 2 milliseconds out of the 35 that I'm giving my algorithm. It's not huge. Like, okay, this one has more. 82, 1.33. So this one almost 3 milliseconds. And you can imagine that as this is going on and turns are adding up, probably, the garbage collector probably keeps going, getting slower and slower, or doing more work as more objects are being created and released. So anyways, that's like, that gives us an idea. So ideally, I want to get to, with my object pooling, where you don't see any garbage collection at all. That would be awesome. And it doesn't look that bad right now, but I've done this before, and there's some places sometimes where the garbage collector would take like 7 to 12 milliseconds. That's huge, considering that I only have 50 milliseconds. All right, enough talk, I guess. Let's code. Let us code. So object pooling And there's a bunch of different objects I want to be able to pool as I'm creating them in my Monte Carlo tree search algorithm, specifically the simulation part of it. But not only. I guess, like for instance, the node object itself, I end up creating quite a few nodes, no doubt. Even though the deepest I ever get is like from 10 to 15, but the tree, can be pretty wide. So on any given turn, there's probably a bunch of nodes that are being created and destroyed right now. And also for each simulation play out, I end up creating a lot of state objects, and actions, because I'm generating every possible action at every simulated turn. So really, there's a bunch of classes there that I would like to pool. So, and I was thinking about this. It's kind of a cross-cutting concern, right? I ideally I don't want to have to pollute my classes with like some weird logic about pooling and yeah, so or having to inject in the constructor some kind of pool manager or whatever. So one thing I thought I could try to do is use a decorator. And there's a decorator pattern, but um, I'm thinking of using the actual language feature now that is available in TypeScript and JavaScript, I think, although it's experimental. But yeah, so essentially it's a function that takes in a constructor and then can do stuff to it, um, and modify it. And so basically very similar to the decorator pattern, except that it's really easy to use because you can just do uh, say poolable, for instance, and there you go. That's all. Now every time I would do new node, well, it would go through that decorator. Pretty neat. So let's do that. Let's create a, where do I want to put this? I'll put it in the engine folder for now. We're going to call it poolable. And it has to be a function. So export function. It's a function that takes in a constructor of type T. So we need to make this generic. So what are we? T. Can I do T extends? No. T extends. Yeah. So T extends new. I haven't done that in a while. Let me see if I can pull up some. Oh yeah, I was just looking at that, right? I started looking at it earlier. Okay, that's what I was looking for. Right. So an object constructor takes any amount of arguments of any type and returns an object, basically. So I get what's going on here. Let's just copy it, I guess. Right, okay. Let's give it a name. We decided to call it poolable. So let's do that. Yes. Take Make it easy. And that's going to return, are we going to, I don't know yet. You can have your decorator, class decorator, either actually return a new constructor or not, just do stuff to just get information out of the constructor or modify some of it. Let's see, we want to, all right, how are we going to do this? I have an idea. Let's create a map of pools. And the type is going to be, it is a mouthful, isn't it? Yeah. I could probably like, I could extract that to a named type if I wanted to, but this being pretty much all throwaway code. Yeah, let's see. This is going to be, the key is going to be a string. I'm going to use the constructor's name, the class name, as the key, and it's going to contain, I guess, just an array of objects. It's got to be, yeah. I want to be able to store different things in it, so it's not very, it's not very, let's just do that for now. Oof, I hate doing that in TypeScript, but that's what I'm doing. Although, I mean, I could also have, no, that's the thing. I want this to be kind of generic. Would there be a way if I say, I'll think about this as I go, but we've got our map here. And what I want to do is go, all right, so we're getting our constructor. I want to get the constructor's name. All right, the constructor's name. Yes. And that's going to be the key in the map. Okay, so I do need to return a new constructor. So essentially, what would that be? Not returning a T, I'm returning a function that returns. Oh, let's just look at how they did it in the. Oh, they didn't type the return. Oh, well, I could do that and let the compiler tell me how it thinks it should be done. That'll be interesting. Let's forget about that for now. So return, I guess class extends constructor, right? Yes. Can I do that? Maybe not. Class extends. How did they do it? Must be something, yeah. Extends. Why is it complaining then? Declaration or statement expected. Maybe because I've got nothing in there. I'll just copy this for now and see what happens. Maybe I should have just done that from the start. Yep. Why am I not using keyboard shortcuts? I don't know. Oh. That's just a stupid. Yeah, there you go. So if I do that, we'll make a difference. Good. And I was looking for the return type. Oh, wow. Okay. I'm not touching that. Let's just leave it like that. All right, so what we want to do is essentially class constructor. All right, so let's give our class a constructor function. Can I do that? I guess not. Mixin class must have a constructor with a single rest parameter of type any. Yep, okay. I think I can do that. So basically the exact same thing as this here. Or is it? Yeah, I think so. Okay, good. And now what's it complaining about? Constructors for a derived class must contain a supercall. Right. Right. So let's do that as well in here. Super. Pass in the args. Nope. Doesn't like. Oh, what happened to my? What happened to my? There we go. Okay. Now what I want to do, and I've never really done this before, but I want to basically do this before. So pools dot set. I want to basically set this instance. I want to store this instance that I'm creating here inside my map. And I wonder if that's going to work. So we're about to find out. Constructor.name and this. That work. The question is, what does this refer to? Super must be called before accessing this in the constructor. Okay. All right. So I have a feeling this normally should refer to the class I'm in right now. So which is what I want, right? Okay. So technically we should end up with that instance being stored in the pool. I've got it typed as any, which is not great, but I can't really think of a way to nope. Can't really think of a way to well, I could do like type and then just list all the different types that I plan to put in the map. That's not super useful either. So I'm probably just gonna have to end up casting, which is fine because I'm using the constructor name as the key, so it won't be a problem. So let's try that. And okay, so let's try it. Let's try first with our state object. Actually, I can just do all of them. Let's just do that and just see what happens. So at poolable. There you go. Okay, so right off the bat, it looks like we're breaking some tests, right? Let's see. Right. Did not think about that. I don't see why we would, though. Why would that break the tests? Let's go find out. Type error cannot read property tuple of undefined. And that is like deeper. That's a deeper problem. All right, let's debug the test. Because I really am not sure what's going on here. Do that, and I need to switch this over to my tests. Let's see what gives. Oh boy. Okay. State is of type state, so that's good. Right? It means it created the thing properly. Let's go in, see where we actually get that error. Actually, that might be a quicker way to do it. Is to just not break and let's restart this. Just let it break on the error. It didn't. It just, let's try it again. Oh, that's interesting. That is interesting. How about caught exceptions? Maybe. No error from binding. All right, cool. Let's look at the stack. Where's the stack? There it is. Start sync module. What the heck is all that stuff? Can I just go step out of this thing here, please? I said, come on. How far up do I need to go? Like in deep in the framework, the test framework stuff. Okay, this is horrible. Get that. Let's forget about the cut exception. But it's saying type error cannot apply, so it would be inside this thing here. Let's try it again. Let's put a breakpoint here. Actually, I want it to be specifically for this test, so I already have one here. Let's use this one. Let's forget about that one. And try that again. All right, let's get in there. All right, so I'm doing inventory dot apply. What's the inventory like here? Action. Well, that's a problem. Right, I've got, whoa. Okay, that's interesting. So type, it's shoved. Oh, okay. Okay. How can that possibly have happened? Let's go back up. No, not in that thing. Here. So where's my state? Play cast action. Chosen action. Can I? Here. Chosen action. That doesn't make any sense at all. I'm gonna try that again. Something weird going on. Oh, did I? Where's the action thing? Oh, I did put poolable on action. I thought I put it on state. Silly moi. Okay. Well, which is fine, I guess. But now I think that the problem is extends new. I'm taking the arguments here, passing, maybe. I've got the constructor. Yeah, that's not right, is it? I need to pass in the argument spreaded like that. I think we just fixed it. Yeah, we did. Okay. Yeah, that was a easy mistake to make. So basically, I was passing to the parent class all of the arguments from the constructor as an array, just one item, when really I need to take whatever's in the arguments array and spread it out into the different arguments. So that, all right, so that fixed it. At least the tests are passing. And I want to say, yeah, let's run it. Let's build it and run it. Oops, not what I want. Come on. All right. Should have updated here. Let's see if it crashes or if at least it runs the way it should. All right, so it doesn't look like it crashes. I don't know if it helped any. Doesn't look like it, but that's just one of the types. Hey, I won this one. Cool. All right, so here's what I want to do now. Will that be a, yeah, okay. So I think the fact that I've got this kind of like in the global scope, this map here, I think that should be enough to confuse the garbage collector into not trying to collect any of those objects. Not sure. We'll get to test that just in a bit. But what I want to do, oh, actually, here you go. I know how to fix that for sure. Let's import the pools into main. And what we'll do is at every turn, we will, let's do that. Where am I logging stuff somewhere? Not really. This is after doing the turn. This is after doing the action. All right, let's do that here. Let's do pools dot size will just give us the number of pools we have. I'd love to get the actual amount of objects stored within. So we're going to have to do something a little fancier. So let's just do for pool of pools. Probably could have used a for each too, but whatever. Let's do pool dot length, I guess. Or no, that gives me the entire thing, right? That's the entire map entry. Yeah, the string and any. So I would have to do map1 and just length, I guess. Right, it doesn't know that it's an array. It should. Did I not type it at least as an array? I did not, so we could do at least that. Oh no! Right. Right. So I need to do this. Then true. So what I need to do is it's a bit more complicated, but it's not the end of the world either. All right, so pools dot. Well, what does get? No, that turns are undefined. All right, so let's use has. So pool has constructor dot name. Okay, let's use that in an if statement here. So if our pool has that key, then great, let's get it. Let's get that key. And that's going to be an array, so let's store that. Const pool. And then we can just do pool dot push our this. And object is possibly undefined. It is not. I'm checking. I am checking if it has it. You bum. So there. Telling you it's not undefined. So that's cool. Otherwise, we're going to have to create it. And that's going to be as simple as doing pools.set constructor.name. That's our key, and our entry, since it's the first one, an array, and I can shove that in there. There you go. Am I missing a curly brace or something? Oh, I am missing a parentheses. There we go. Okay. That should work. That should work. Where was I? What was I doing? Oh yeah, logging. So I want to do pool one dot length, right? That's what I want to get. I want to log that. How are we going to do this? We're going to do it that way. We're going to do console.error. For those of you that aren't familiar with the CodinGame platform, where our bot communicates with standard out and standard in. So we can't use your regular log or warn level outputs because that will be considered like a message that you're passing into the game. So to log, you always have to use the standard error. Right. Probably just I want to be more specific than that. Let's make it an object just to wrap it up. And we're gonna, the name's gonna be pool dot name. No, pool dot. Oh no, it's right. This so that's going to be name of the object, and this has to be a string. So let's interpolate it using this here. Like that. Would that work? Maybe not. Expected a comma. Did you now? Why did you expect a comma? Property assignment expected. Yes, yes, yes. Okay, well, you're annoying me, so let's do that instead. Because I don't. Oops. So we get that, and that, and another one of those. Like that. Okay. So that should work. Let's see. Build it and run it. Okay, I think we crashed. Yeah, timeout. Well, that's not good. It did go through the first turn. A few turns, 3 turns. And then it said, I'm out. Let's run it again. So I wonder, it's probably that log that is causing the problem. Yeah, that I just introduced. We should still be able to see it though. Oh, there we go. Holy crap. Yeah, so you, you see what I'm talking about? 307,000. So I wonder if I'm running out of memory more than timing out. Although I'd probably get some kind of different error. No, I'm not running out of memory because we did try it without the log. So let's take a look. Pool. I guess this, like checking the length of an array that has 30,000 object, I don't know how that's implemented, but I could see that being an expensive operation, although I don't know, you'd think they just keep a running tally. Well, that's a bummer. Let's remove it. See if that helps any. All right, so we're still crashing. We are still crashing. So the only difference between the code that was running and the one that's not anymore is the fact that I'm importing pools here. I'm not even using it though, but let's remove that and see what happens. Because yeah, it might very well be a memory issue. I don't know, I'm not sure. Guess we'll explore, find out. Like it says I'm timing out, but it could be because I'm just running out of memory. All right, let's run it. Oh, this is not looking good. Maybe, I don't know. Yeah. Okay. So interesting. Were we just lucky that it actually ran the entire game that one time that I tried it after implementing it? Maybe. It's pretty much all of them seem to ay ay ay, yeah. Huh. So that's not good. That is not good. Everything else is back to normal. Yeah. So why would that be a problem? Maybe decorators aren't optimized or something. It is an experimental feature. At the same time, I mean, there's bound to be a cost to adding 30,000 elements to an array. Hmm. Well, well. How do I get around that? I'm trying to solve a performance problem and I'm creating another performance problem. That's not. I was hoping that, okay, yeah, first, before we go any further, let's test it in my little playground. Change that to start. See if it crashes here too. Let's just pull out the DevTools on the side so we get the console. Console, please. Thank you. All right, let's do this. Okay, so no crashing here. Good. It did take a few turns though. So let's keep going. Don't care what we're doing. Let's just do that. What you're seeing, it looks like errors here, but like I said, it's because we're using the error channel. And this is all just regular logging stuff. Okay. So far so good. Rest. Next. 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 Of course, the memory limitation might be different. Probably is, too, with the node that that they're running there on the CodinGame server than what Chrome is running. And that's probably something we can check. That seems like a hassle, though. Oh, that's interesting. Oh, it's me. I did something stupid. Okay. Let's do that then. Okay. So far, so good. All right, let's do this. Let's take a heap snapshot. Well, actually, I should get, okay, 105 megabytes, which really isn't that bad. I think Node out of the box, if you don't increase it, has 700 and something megabytes of memory allowed. So we're nowhere near that, and I'm already at turn 20. Okay. Notice how it keeps going up. The memory usage as we keep going with the turns. But it's not timing out. Well, although I don't have a mechanism in this to, which I should probably put one to tell me how much time the bot took. Right, so it probably isn't a memory issue. It's probably just the time required to do that. Let's take a performance snapshot, I guess. Clear all profiles. Let's reload this. Let's go with performance. Record. Do that. And then do that. And then do that. And do that. And do that. And do that. Let's do 2 turns. Well, not 2 turns, but 2 goes at the entire thing. Okay. That should be enough data. It's going to be hard to find something meaningful because it's probably something that, like, yes, it doesn't take that long, but it's ran like 30,000 times. That adds up. So obviously the GC is still going because we don't have pools for everything. But that's not what I'm interested in right now. I'm interested in finding out, am I running this? Is probably it here. Can I get more information on this now? Add. No, that's not it. But I'm pretty sure what we're seeing here, and see it's in get valid actions. Although I would expect some kind of, like, to see poolable as a function call. But I don't anywhere. Get valid actions. Array without holes. That is definitely, that is something. To consumable array. Array without holes. Let's take a look at the generated JavaScript from my TypeScript, because decorators are a pretty recent thing. They're kind of experimental, so it's probably compiling it to some weird thing. Not sure. Let's just do Control F here. Poolable. All right, so exports of pools. Function poolable is a constructor. Return class extends constructor. So that looks a lot like, right, what I'm doing. Poolable. Let's see if we can find out how it's applied to the action constructor. Action, there you go. Okay, action 1, decorate. Metadata design param types. Okay. So I guess I'd have to find out what decorate does. Oh boy. That's not Yeah, no, I'm not going to try to decipher that. Forget that. Okay. That's a bummer. Um, so what are my options? If I want an object pool, and this is taking me too long, is there a way to maybe benchmark it better? Yeah, probably. There's probably a way to do that. If I let's see. If I did well, really, let's think about this. Let's pretend that it takes 30,000 times 0.2 milliseconds. That would be 6,000 milliseconds. Whoa. That would be 600 milliseconds. Yeah, that's problematic. Okay, so that would be still way too much. The thing is, I don't know how long it does take. Because I can't find, can you do a search in here? Control F? Oh yeah, look at that. Cool. Yeah, there's no reference to poolable. Well, that's a bummer. How about decorate? Decorate. No. What is this? Nope. Huh. Hmm. Well, kind of hard to know what the problem is. Why am I timing out? Let's see. Let's think about this. I could. How could I isolate this stuff so I can kind of know how much time is spent? Can I, if I do it inside, that wouldn't give me what I want, would it? Well, I guess it would be better than nothing. I could time, oh, I can't really, because I can't have something after the return statement. So I'd have to, Hey, Pi Master. Why am I not submitting in TS? Just because I can use Webpack to bundle all my code into just one file. It's easier to do. I know that TypeScript's compiler has a concatenating option or something like that, but it screws things up with the exports and import statements and all that. Last time I played with it anyways. I haven't bothered taking a look since. But yeah, like I was telling someone else, I'm probably going to do the next challenges in another language anyways, so not bothering with, building a little tool that would strip everything I need from the TypeScript and being able to submit it. That plus JavaScript code, because it doesn't have all the types, is less characters. And I guess that's better. Oh, you're doing it in Python this time? Yeah. A lot of people are doing it in Python. All right, so I want to be able to basically benchmark this function. The thing is, it's a decorator, and it's being called, uh, it's being applied to this class here, and I have no idea how I can benchmark it. I guess another way to do it would be to try to benchmark wherever I'm doing a new, okay, so I know. It's not the best way to do it, not the most accurate way to do it, but this is where I create like the vast majority of action objects. So I could wrap this in some sort of timer and try to get some information out of that. At the same time, I know that's the problem, so whether I find out how much time exactly it's taking or not doesn't change the fact that this is the problem. So I don't think I can use a decorator. Although the decorator itself might not be the problem, the fact that I'm using a decorator, it might just be the adding of. Okay, so in that sense, it would make sense to kind of, okay, let's try to time this. This whole thing here, where we're adding it to the pool. All right, let's do that. So I'm just gonna do this here. So helper function that I use. Const start equals now, and this will be the end. So what I want to do, I want to keep a running tally of this thing. I'm going to make this a let. Pooling time, I guess we can call it. And that's just going to be a number. Initialize that to 0. And then I can just do now minus start will give me the amount of milliseconds that have elapsed. And let's add that to our pooling time. Pooling time plus equals the result of this. Right? I think so. And that will be in milliseconds. So to start, although it'd be better if we get it per turn. Yeah. Yeah. We can do that. We can do that. Can't we? Yes, we can. We just have to, at the very beginning here, do pooling time equals 0. Am I importing this? I'm not. Why? Yes, I am. What's it saying? Cannot assign to pooling time because it's not a variable. Right. You suck. It's a reference. Right now, I'm just exporting a reference to. Ugh. then. I guess it's not the end of the world if we don't do that. It'll still be useful information. All right, so let's just log it. Let's start with that. Get a little bit of data, and let's do that right here. Right, gotta port it first, so. Oh, right. Oh, I wasn't. No, what am I doing? It's not poolable that I want. What's it called? Pooling time, pooling time. Pooling time. Now, there we go. Okay. See what happens with that. I thought this was going to be easy. All right, so it crashed again, but we're going to get a little bit of data out of it. So I guess this is incremental. So, all right. 74 milliseconds. Ha. The very first turn. The very first turn, 74 milliseconds. Yeah, so you can see how that is going to be a problem. Now it's going to be less on the subsequent terms, right? We go up from 74 to 78 points, so that's still like 4 or 5 milliseconds per normal turn. Yeah, so this went up from 78 point something to 83, almost 84, 84 to, oh, this time around didn't take that much. I guess we didn't create that many actions for some reason. And then 84 to 87. Sorry, on average, I think we can say that it's close to, between 3 to 4 milliseconds that this thing is taking, which is huge, out of 50 milliseconds. And it's way too much compared to what I'm trying to save in the garbage collector's time. So, what are my options? Can I reduce this? Well, there is something I could do. We are creating a bunch of actions here at the very beginning because we've got more time to compute. I could actually prime the pool with empty objects and in the first turn, since I have about a second, so I could do that in the first turn, and then instead of creating a new action and adding it to the pool, I could just reach into the pool and use an action that is not. So yeah, so that's like implementing a real object pool with, like, you need a flag on the object that says if it's in use or not. You need to manage the yeah, two lists basically, or some sort of index um, where where the objects that aren't in use in your pool are, so that when you call create or whatever or initialize, it returns an empty one that's not in use anyways. Oh, I don't know how much we'd save by doing that. It'd be interesting to find out. Would it be super complicated to do? I don't know. Let's think about this quickly. Could I do that inside my... Okay, so right now this stores whatever we're creating inside our map. What if... All right, so what if we forget about the map? We actually have some sort of pool class. I could add stuff to it. Could I take stuff out of it? So somebody calls new, the decorator's here, the constructor's being passed. Yeah. Then I would need to say, no, no, no. Do not construct the object, my dear sir. Instead, I want you to reach into the pool, find an object that's already there. Yeah, that could work. That could work. Let's see. I don't know if the function, well, I guess as long as we're returning, what was, oh, okay, crap, let's get back. I'm gonna have to take a look at the signature there. The return type is complicated. So the return type is an object, is a union, no, and that's a mix-in, right? It's a mix-in or union. I can't forget what the, well, they're the kind of the same thing, I guess. It's a mix between those. Okay, so an object that has a constructor with any number of arguments of type, yeah, with any number of arguments of any kind, of any type, and its prototype is poolable. So it's a mix between that and very interesting. Let's see, what if we were to do something like this? Let's forget about all that. Have a class that we're going to be calling, I don't know, pool? Kinda? Can... All right, let's go with it and see where that leads us. So we have a pool. Obviously, we need... actually, I don't think I need to pass in anything to constructor. What I do need... What do I need? What do I need from that pool? I need the pool to give me an empty object. So I'm essentially like the pool's going to be replacing the new, right? So where I would do new object, I would now do pool.create essentially. So cool. I don't know if I can make this generic though. Try, see what happens. So okay, so let's see if we can do it. So pool of t, cool. So now create is going to be returning a t, right? And I need to call create with whatever arguments I'm pointing, and that's where it gets complicated because I can't, so I guess I need to use this kind of, is that the way to do it? No, it's the other way around. There you go. Okay, so we can't actually type. If we want this to be generic, we can't really type the arguments, but let's see. Let's see how far we can get with this and if it's usable or not. All right, so that's going to be something that we need. What else do we need? Well, we need, I guess, a dispose. Right. How do I want the, yeah, okay. Yeah, let's give it a dispose. Dispose. So basically doing the garbage collector's work, but at least we get to control when we do it. And we're going to be doing it less than the garbage collector does it. So I'm not convinced we're going to be gaining any significant time, but it's an interesting exercise. So, oh yeah, the complicated part though is that it would make more sense to have a function on the object itself that's called disposed. Although I can I can do it by reference. Yeah, that would work. Although it would be super inefficient though. Right, I'd have to, so, okay, this is what I'm thinking. Let's say I have my pool here, which is just an array of T, I guess. So T array. And so whenever I create, I call create, it would have to look inside the pool, look in pool for what? I would need two pools. All right, so, okay. So let's say in use pool, and available pool. That is not the best naming, but okay, so that way I call create, like cool, let's look in the pool let's look in the available pool. What the heck? Okay. Pool. If available, we'll just return that. And if not, create, so new up, AT, and then actually new up, what, okay. For new up a T and store it in use. And return it, right? Return it. something like that. So that's cool. That's would be the algorithm for create, right? Look in the available pool. If available, just return it. Oh, it's not as simple as that. We also need to, uh, what is up with my tabbing here? Okay, whatever. So if it will return that, well, no. First, so why am I putting this on? Let's do it like that. No, stupid formatter. Okay, so like that. If available, cool. Remove from the available pool. And then add to in use pool. Yes, and then return it. Return it. Okay, so if it's available, remove from available pool, add to in use pool, return it. If it's not available, new up a new T, store it in the use pool, return it. Good. I think those are the two cases I need to worry about when I want to create something. Now, if I want to dispose of it, so you're going to pass a T. So let's just call it object, obj of T is what you're passing to me. This won't return anything. So what I want to do is look in use pool. This is still going to be super expensive though. Because, yeah, there's got to be a better way to do this. So this is fine, right? We just need to check if there's anything in there. So that's a pretty inexpensive thing to do, and then we just pop off, you know, anything from the array from the stack, and we're good to go. But in here, I'm saying, okay, this object here, which is in use right now, well, it's not anymore. So I can take it from in use and put it to available pool. But let's pretend. So that means I need to search the pool. I don't know how that's implemented in JavaScript. Probably some sort of merge sort, or no, not sort, but binary. I mean binary search, which I can't remember what the O complexity thing is for that one. It's better than iterating all of it, but still, like thinking that we have like tens of thousands of objects in there and we're going to be disposing of them oftentimes, that's not efficient. So solution is, aha, okay, let's not make it an array. Let's make it a set. Let's make it a set. A set of what? A set of T. Right. And now I can do look in use pool. Normally it would be there. So I guess I could probably skip checking to make sure that it's in there. Right. Yeah, that'll save us a little bit of time. We can just take for granted that whatever's out there has to be in the use pool. Otherwise, there's a problem with our implementation. So, okay. So all I really need to do is basically, oh, I can just do it that way, right? This lot in use pool dot delete. Yeah, simple as that. Right, because it'll find it by reference. And that's like, I don't know how this works behind the scenes, some sort of hashing thing. It's a heck of a lot more efficient, no doubt, than having to somehow search through an array. Is my hope, anyways. It is my hope. Right, because the set is, I think, it's like behind the curtain is really a map where the key is the value, right? So that should be pretty efficient. All right, so that's taken care of. Great. And what I like about this is I don't have to fiddle with the actual objects I'm trying to pool. I don't have to go and add like a in-use flag on the object itself. Now for this is going to be a little more complicated. So look in the available pool to see if there's anything there. So this dot available pool dot length. Right. So let's do that, and then cite an if statement. Oops. And right. Okay. If it's available. Right. That's where I'm at. Remove from available pool. So I just do this. We're going to see this const object equals this not available pool dot pop. Great. Thank you. And once I've got that, I want to add it to the in use pool. Oh, it's not a pool anymore. Well, it is a pool, but I mean, it's not an array, it's a set. So dot add, yes, the object. Thank you. It's not liking this because of what? T undefined. Yeah, well, I already said I checked to make sure that there's something there. Okay, and return it. So not too bad. So far, so good. Now, if that's not the case, so that's taken care of. Good. Don't need you. Now, if not, I need to create a new T, and that is where this gets interesting. Because it's generic, how can I do this? Don't know that I can. This being JavaScript and there's no reflection. And the types aren't really available runtime. All I'm passing is a set of arguments, so really the function at runtime doesn't know. All right, it doesn't know what we're trying to create. I don't have access to that variable here. This is just for the benefit of the TypeScript compiler. I could pass in, all right, here's one way to do this. Oh, actually, no, there is a way to do this. There's definitely a way to do this. All right. Yeah. Okay. So we're basically just going to pass in our constructor function, which is it's just a function. It takes args, any, and returns returns t. Yeah. Right, so let's save that in a private variable. And now I should be able to say, all right, you want me to construct a new objet. I know exactly what this is, so I could do this dot. This dot, no, I gotta do new, right. This, not CTR, pass in the arguments that way. Yes, no, yes. The args are going to be, yes, right. Yes. Okay, it's not liking this, eh? New expression whose target lacks a construct signature implicitly has an any type. Lacks a construct signature. Oh, I probably have to use something that, okay. Let's use that as the signature. Right here. Does that not work? Oh, it's got to be like an object. Although I don't see why. That's probably just, that would work too, yeah. And now it's happy. Yay. Right? What am I returning? I'm returning a t. Yes. So if I was to save this in a variable here, it would be a type t. Cool. That's what we want. And actually we do need to save it, so let's do that. Let's call this obj. The other one, passing that in. So new up t, store it in the use pool. So this dot in use, which is our set, store it in there, and then just return it. All right. Okay. So not that bad if I didn't screw this up. Now the question is, how do I use this with my decorator? So somebody's calling new action. And now it's decorated by my poolable thingamajigger. So it's passing in a constructor. We've got arguments that we have available. Can I return? This is what I want to know. Can I return? Oh. Ha. Haha, okay. All right, I got this. I can return, so let's see. Because this needs to return basically a constructor function. So I wonder if if I returned, which is this basically, although it might not be the correct function signature, but if I was to create a pool here, so const, let's call it an action pool, right? New pool. It's, oh, actually, can I just do, we'll see. Pool, and if I do action, all right, that's great. I don't need to specify the T. I believe it has inferred it from my use of right. So if I was to do action pool dot create, yeah, it's returning an action. Awesome. Okay, so if I did that, action pool dot create, what would be the type? That's essentially the function signature of a constructor, basically. So it might work. The thing is, this is generic. Now I've got to specifically hand it the correct pool. So how do I do that? Ugh. Well, I could come back to my yeah, okay. All right. So let's go back to having a map of pools. Uh, pool. Is that going to work? I don't know. Seems weird. And so yeah, let's try to type this here. We need this to be a string, and we need this to be a pool. A pool. But this is generic, so I need to tell it that I don't know. I can't tell you exactly what it's going to be different things. So now if I have a reference to pools, I can do this. Pools.get, pass in the constructor name, and boom, I've got the correct pool. Right? I've got the correct pool. And now that I have the correct pool, I can do, I can return pool.create. And I'm not calling it because I want to return the actual function, and that's going to be called oh, wow. Can't wait to see if this works. So then it's just a matter of priming my pools map with all the different things that I want to have pooled. So I want to have the state. Well, actually, let's not go crazy and just test it with the actions first. Okay. Looks like I might have some failing tests, so, or what's going on here? Right. Okay. Unable to resolve signature of classic greater when called as an expression. Types any is not assignable to type void or type of action. Type of action. Type it provides no match for the signature new. ID blah 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 blah. Returns action. Uh-huh. 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 Right. I need to cast this, I think. Because when I get here, right, it doesn't know. Um, so as pool of T. Ha! I don't think that was enough though. I think it's still not happy. Oh, but it's not as unhappy as it was. Got rid of one of them. Type args any array to type of action provides no match for signature new something 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 returns action. Why type of action? Ah, right. This returns the constructor? No, it returns a T. Doesn't return a type of. Actually returns it. Um, hmm, 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 hmm. I wonder if, like, doesn't help that I don't know how this works, how the decorator is implemented. Like, is an actual new being called on whatever the return of this will be? Because then that would be a problem, obviously. And that's probably why, it's complaining. None of my tests are failing though. So that's a good sign. Right, where am I newing up some actions? Right here. So none of those are failing, meaning that this is working. You would think, anyways. It is just not the right type. The compiler is not happy. Type is not assignable to type of action. So I'm basically saying this needs to return a type of action. Really? What if I called it? That wouldn't work, right? So I'm actually returning it. Oh, it does? Huh. But then, well, I guess I can just pass in the arguments from the constructor. How did that work again? I had that working before. Can I do that? Yes, I can. Args. 1, 2, 3. No. Wasn't that what I was doing before? What's it saying? Cannot find args. Right. So yeah, that's obviously not. What do we have in our constructor here? Constructor dot arguments. Spread them out. Would that work? My tests aren't failing. And I sound surprised, yes. And right, that's just yeah, forget that. Although I don't know that I want to get rid of this yet. Might make sense to do some benchmarking for that too. Why do I feel like this isn't going to work? It's not complaining, so I guess I'm just returning the object itself. I have a weird feeling about this. Okay. So that's cool. We've got our pool. We've got this. We've got that. What else? We're not creating. We're not disposing, right? I need to dispose. And that's going to be happening. How can I do that in a way that's not completely annoying? Well, I could just straight up go through. Yeah, I could do that. All right, let's do this. Dispose all. This not in use. Pool. Um, Clear. That would get rid of everything, but first I need to put everything back into the available pool. Bummer. What if I get turns an iterable of values in the set? So I get the values. I can probably do. Okay, I can probably do this. This thought available pool. And use push, I guess. Push. And then I just need to do this because it's an iterable anyways. I don't know how efficient that's going to be. This is a function call. Okay. So that would work. And this, that, in use pool, we can just clear. And this would happen every turn. I have a bad feeling. I don't think this is very performant code. We're about to find out, I guess. So I'm going to need a reference to actually all of our pools, really. God's pools. Let's get, don't need that here. I don't, yeah. Let's grab this. We've got our pools here. We'll get back to that later. And right here is where we're going to dispose of them. So pools dot dispose, no, pools dot for each. For each pool, my rank at the moment is I think 1200 in the Bronze League. It's not that great. I didn't implement the Bronze League rules yet, because I'm trying to increase the. Yeah, I'm trying to do that, but unsuccessfully. So far, anyways. Might be just a huge waste of time, and I should be changing tack. There's only so much you can do with JavaScript, right? But you can do a lot. Thanks. Thank you for the encouragement. So, all right. So just iterate through all of our pools, and we want to do pool.dispose of all. That's a pretty simple mechanism. Right. So let's watch it crash and burn, I guess. All right, let's build this. It compiles. That's a good first step. Well, let's see what happens. Will it time out again, or will this have helped? Well, look at that. It might just have worked. I think you might bump up time spent so far for second round to bigger to 38 maybe. Oh, yeah, the time I give the my algorithm, you mean, for the second turn and going forward? Right. I might be able to. Yeah. We'll see. So this was just for one of the. Well, I'm just glad that it's not timing out, and it seems to be working properly, ish. All right, I did win. Cool. If we look at, let's look at the stats, see if it helped any in terms of how many simulations we were able to do. I don't see a significant difference here. Not really. But like I said, it's only one of the objects. So, all right, let's roll it out for all of the objects. And the neat thing is that I can just do, all right, first I need to add all of my pools. So I want to do this for the state object. End up creating a bunch of those. State. Okay. Then I need to Ingredients is another one that I create a lot of. New pool of type ingredients. Okay. Oh, didn't import it. Oh. Okay. What? What do you mean? Where's my ingredients? Ingredients. Right. Pretty sure I spelled that properly. Ingredients. What? Oh, I see what's going on. There we go. Then if I go like that, I should be able to do that. Yes. Okay. And we want to pool our nodes. I gotta name this to pool. The node pool. I think it's just node, but I'm not exporting it, I think. Export the node here. I think I'm gonna have to import it manually. If I do this, let's try it again. Yeah, because there's a node interface and it's screwing up with the. So import node from where is it? It's in the bot, so I need to go back up one. Bot. Cannot read property rest of undefined. Say what? So one of our tests just failed. This one here. Nope. That's not a test, that's an import. What the heck? But it looks like it's trying to run a test somewhere and it's deck. That is weird. Action type. Strange. Maybe Wallaby's just doing some free games. Source bot, engine pullable, state deck state test. So it stemmed from the state test. It's trying to import deck. And then in trying to import deck is trying to import action and action type. From state, and state is trying to import pullable from pullable here. Oh, is it some sort of circular dependency kind of thing they're not liking? Might be. That might be it. And bot. It's trying to import node from bot. And it cannot read property rest of undefined. That's really odd. Okay, let's turn that off. for now, and let's try running our test with Jest. See if that fails. Technically it should. Yeah, okay. Action type.rest. Oh, that's interesting. Why? State, action type, rest is there. Huh. Probably because something's happening as it's trying to create the action. I'm gonna have to debug this. But it is past noon and it is time for lunch. So thanks for sticking around or spending a little bit of time on my channel. Hope having fun doing the coding challenge if you're involved. I'll be streaming again tomorrow, 10 to noon Eastern time in North America. Bye.